So today we'll be demonstrating capillary rise, which occurs when you have a tube of sufficiently small diameter and you place one end into a reservoir of liquid, and what happens is the liquid is actually drawn upwards into the tube. Now, we can calculate the height at which the liquid rises using this equation, where h is the height of capillary rise. The surface tension and density of the liquid are known. The tube is of a known radius, and there is a known contact angle of the liquid with the inside of the tube, and g is gravity. So in this demonstration, we'll be using this 0.1 millimeter radius glass tube with water. So what I've done is I've taken values that we'll use in our experiment and plug them into this equation. So here we have our surface tension and our density of water, the radius of the tube we're using, gravity, and we'll take the contact angle as 0, which we will have once we allow the liquid to equilibrate in the capillary tube. So this equation comes out to be about 14 millimeters. That means that when I take my capillary tube, which I've attached to this ruler, that when I place it into the water should rise in the tube about 14 millimeters. So here I have a pool of water, which I have added blue food coloring to for visualization, and I'll place the capillary in the water and set it down. And we can see here that the water actually rises to about 14 millimeters, which is roughly what we calculated earlier. And using this equation, we can also figure out the maximum value that a tube can have in its diameter for it to exhibit any capillary rise at all. Because as the radius of the tube gets larger, the height actually gets smaller and eventually goes to 0, where there's no capillary rise occurring. Now this value comes out to be about 2.6 millimeters in diameter, which means that if you have a tube that is wider than 2.6 millimeters, it will exhibit no capillary rise at all. To demonstrate this, I have your regular drinking straw, and I will place it into the water with the blue food coloring. As you can see, there's no capillary rise occurring due to the large diameter of the drinking straw. Now that means when we want to draw up any sort of drink into our drinking straw, we need to create a vacuum on one end, and in that manner, the liquid will rise up into the tube and eventually into our mouths. So that is the principle in which capillary rise occurs. Thanks for watching.